Hi everyone, today we start our study of Unit 2, which covers properties of triangles and also parallel lines. Our focus for today's lesson will be on parallel lines and transversals. So our learning target states that you will be able to identify and solve problems using angle pairs created by parallel lines and transversals. Our key terms, well first, this word transversal that I keep bringing up. A transversal is a line that crosses two or more parallel lines and creates pairs of congruent and supplementary angles. Okay, so to be a little bit more general, you could have two lines that are not parallel and they could be crossed by a transversal. Okay, so what we're doing today is looking at a specific case where the lines are parallel, and we're going to talk about some specific relationships between the angles formed. So just a little refresher, parallel lines are two or more lines that are equidistant at all points and they never intersect. So some indications that lines are parallel. You might see little arrows on the lines that would indicate the lines are parallel to each other. I'm going to use this other set of lines to show you that the arrows might be filled in to indicate that the lines are parallel as well. When we talk about two parallel lines being cut by a transversal, the space is divided into exterior space and interior space. The interior space, I use my highlighter tool and highlight this in yellow. The interior space is the space inside or in between the two parallel lines. Okay, so we're going to say the space inside or between parallel lines. So I'm going to write a little note here that this is interior. Okay, so it's between our two parallel lines. The exterior would be the space outside your parallel lines. So everything that I'm highlighting in red is outside of the two parallel lines. So that is our exterior space. So label this as exterior and also label this as exterior. So again, that's outside the parallel lines. So as I mentioned before, we're going to be taking a look at all these special angle pairs that are formed. And I should mention that there is a typo later on in this last box where this says same side. It should say opposite sides. Okay, back up to the top of our box here. So with our first special angle pair relationship, we have a corresponding angles postulate. Corresponding angles are described as two angles that are in the same corner at each intersection, meaning this angle would correspond to this angle. They're kind of like the steps on a ladder, okay? So corresponding angles, when formed by parallel lines, so if we saw little arrows indicating that these two lines are parallel, these corresponding angles would be congruent. Okay, so corresponding angles are only congruent if the lines are parallel. Okay. All right, our next special angle pair would be same side interior angles. So the same side interior angles theorem says that they are angles on the same side of the transversal and inside the parallel lines. Okay, so first of all, this is our transversal. These are the two parallel lines. I'm going to use arrows to indicate that they're parallel. So same side interior angles would be this little angle right here and this larger angle right there. They are not congruent to each other, so notice I use different markings to mark those angles. Now, when same side interior angles are formed by parallel lines, these angles are supplementary. Meaning they add to 180. Okay, so our next theorem, the same side exterior angles theorem. Again, if we're looking at our transversal, we're going to have both angles on the same side of that green line. And if we know our lines are parallel, then same side exterior angles would be this angle, a large angle, and this angle right here. They're both exterior angles, so they're on the outside of our two parallel lines, and they're on the same side of the transversal. So if you kind of put your hand down along that line, they have to be on one side of that transversal. Okay, so if you have same side exterior angles, they are supplementary. And you can kind of see in our picture, one of them is obtuse and one is acute, so they're going to add up to 180. All right, the next one is called the alternate interior angles theorem. All right, alternate means one on each side of your transversal. I'm going to highlight that transversal. I'm also going to mark these lines as parallel because these angles, well, we can always call them alternate interior angles. Alternate interior angles are congruent when formed by parallel lines. So we're looking at this angle right here, that corner, and this angle down here in this corner. So those two are alternate interior angles, and they are congruent. And again, they're congruent because they're formed by parallel lines. Imagine if your lines looked like this, and this is your transversal. That angle would not be congruent to that angle. And that's because the lines are not parallel. All right, our last special angle pair relationship is alternate exterior angles theorem. So alternate exterior angles are angles on opposite sides of a transversal. So here's your transversal. So we're going to have one angle up here, and the other angle is down here. So they're on opposite sides of the transversal, and they are outside the parallel lines. And let's mark those lines as parallel, by the way. And if you take a look at that, I've marked those two as congruent, and that's because alternate exterior angles will be congruent when formed by parallel lines. Okay, let's see how we can use these special angle pair relationships to set up and solve problems. So in our guided practice, in number 1, it says identify which lines are parallel and which lines are transversal. So we have a little bit of notation to talk about. All right. In number 1, the first one on number 1, we should have arrows that indicate that these lines are parallel. So let's add 2 little arrows here. Then we can say that line P is parallel to line Q. So that's a symbol for parallel. Okay. The transversal, again, is the line that intersects those 2 parallel lines. So line T is our transversal. Right. In our second picture here, let's use some arrows to mark these 2 lines parallel. And typically we'll be told that in a problem. So that means that line L is parallel to line M. So just use that single lowercase letter in this case because they're not naming points on the line. And our transversal is T again. All right, the last one, be careful. All right, on this one you have to watch your notation. Okay, so our two parallel lines are going to be line PQ. We can't get away with a single letter in this case because it's not a lowercase letter off to the side. We just have points on the line, so use the 2 points on the line symbol. And we're going to say line PQ is parallel to line RS. Our transversal in this case is this line, PR. So PR with a line symbol. All right, number 2, it says identify the type of angle pair in each diagram. The first thing I'm going to do is identify the transversal for each one. Remember, the transversal is the line that intersects your two other lines. All right. So in the very first example, these two angles are on alternating sides of the transversal, and they're both exterior. So we would say that they are alternate exterior angles. Okay. Now, in this next one, notice that these angles are both in between our two lines, but they're on different sides of the transversal. So since they're on different sides of the transversal, they will be alternating or alternate angles. They're in the interior, so we're going to say alternate interior angles. Right, in the last case, notice that these two angles are on the same side of the transversal. And one is an exterior angle, one is interior. And they look like steps on a ladder. Okay, so we're going to say that these two are corresponding angles. Okay, for number 3, it says given that the measure of angle 3 is equal to 60 degrees, I'm going to put that right in there, find the measure of the other angles. Well, first, I want you to put something down that's important. We can't really solve this unless we know that L is parallel to M. Okay, we would be able to find all of the angles up here just by knowing that first angle, but we wouldn't be able to make the transition to angles 5, 6, 7, and 8 unless we knew that those lines are parallel. So it's really important to make that statement that L is parallel to M. Okay, so first I'm going to go in and find the measure of angle 1, and I notice that angle 1 and angle 3 form a straight line, so they are supplementary. So I'm going to say angle 1 is 120. And how do I know that? The measure of angle 1 plus the measure of angle 3 equals 180. So you can say they're supplementary. You could even say that they're a linear pair. They form a line, so they have to add to 180. So I guess it's linear pane, so let's fix that real quick. Okay, working around the figure, angle 2 and angle 3, you can use one of our older theorems and say that they're vertical angles, so the measure of angle 2 would be 60 degrees. The measure of angle 2 equals the measure of angle 3. They're vertical angles. So I'm just going to write vertical angles are congruent. That is something that's not dependent on parallel lines. Alright, measure of angle 3 equals 60. That was given to us, so we can just say given. Okay. Angle 4, well, you could say it's a vertical angle to angle 1. So we can say that it's 120. So the measure of angle 1 equals measure of angle 4. Vertical angles are congruent. You could also say that angle 2 and angle 4 are supplementary, or angle 3 and angle 4 are supplementary. Okay, now is where the parallel lines come in. All right, we're going to make a jump to get to angle 5. So you can say that angle 1 and angle 5 are congruent because they are corresponding angles. The measure of angle 5 is 120. The measure of angle 1 equals the measure of angle 5 corresponding. Okay, we can go on to the measure of angle 6 now. Angle 2 corresponds to angle 6. That would be a quick way to find that. So measure of angle 2 equals measure of angle 6. I'm going to abbreviate it to corresponding, CORR. So corresponding angles are congruent. Again, you could also find it by saying that 5 and 6 are a linear pair. All right, for angle 7, I'm just going to go with the fact that angle 7 is a vertical angle to angle 5, so it's going to be 120. All right, so vertical angles are congruent. And then finally, angle 8 would be congruent to angle 6 for that same reason. So measure of angle 8 equals measure of angle 6. So vertical angles are congruent. All right, for our last question, we do have to solve for x here. We do need to know that the lines are parallel, so if you would mark those two as being parallel first. All right, it says the type of angle pair. Well, notice that T is the transversal. Those two angles are on the same side of the transversal. They're also in between the two parallel lines. So the type of angle pair is same side, interior. All right, now you may need to refer back to your notes to remember that these angles are supplementary. So they're going to add to 180. So our equation will be 2x minus 25 plus 165 equals 180. And now we're going to solve it. Okay, combine your like terms. Negative 25 plus 65 is going to give us 2x plus 140, because 165 minus 25 is 140. All right, still equal to 180. Take and subtract 140 from both sides. 180 minus 140, sorry about that, let me fix that. 180 minus 140 is 40, so we have this 2x left over. 2x is equal to 40. Take and divide by 2, and we get x is equal to 20, and that's our solution. And of course, you can check it by plugging it back in.